So before we start a rate, check with each other, see if they get it right. Daniel, how did you prepare this test? You did so well.
I would go through the homework and then I would read my questions after I don't think I was getting then I
Most of the homework questions, yeah. All the homework questions on the test. Some of them exactly you like too.
the reason I think I did well on this is because I really caught that. Because I think for algebra and trig, I was trying to still catch up on math. I was supposed to have known, but because that scramble trying to catch up and understand, but that since derivatives, we actually like went through the entire like as I was able to process it a lot better. I was caught up, and I think that helped.
It's Apple, you guys got it? Good. Zephyr, put your shit away. Dude, like, look at your test and the results test score.
Bro, that's my test score, and her score is my score. I don't take Emma's credit. I don't want her Emma's credit.
What?
Emma needs her credit. And
Zephyr, treat things seriously.
No, you don't cancel out. Yeah, no, you have. You already have
All right.
and now you got so you did E1 times 5. Yeah. I got. I got.
All right. So I will have to take a derivative respect to time. I will take a derivative respect to time. Oh no, so to respect to tx. Sorry. D to the dx. Now please write d to the dx in the front, not to the back, because if you take a derivative, you should not. I see people write like here. It just doesn't make sense. Okay, so you take a derivative of this. It's gonna give you 4x. And if you take a derivative of this, it's gonna be minus 5. And take a derivative of x squared y to the q, so it'll be 2x y to the q plus x squared. Is that okay?
yeah.
Plus x squared times 3y squared dy dx is equal to 6 dy dx. And the 25 is going to go away completely, but the 6 dy dx. 4x minus 10 xy to the cube minus 15 x squared y squared dy dx is equal to 6 dy dx. Is this okay?
Yeah.
If I move that to the other side, is equal to 6 dy dx plus 15x squared y squared dy dx. And it's going to be 4x minus 10x y to the third. And you're going to factor out dy dx here. is going to be 6 plus 15x squared y squared. And then you're going to get dy dx is equal to 4x minus 10x y to the third over 6 plus 15x squared y squared. You guys did okay here?
Yeah, but you should know how to do that. You did
Oh, I did it right.
I just very yelled at me.
So I would really good practice.
Super, I mean, seriously, you got to treat everything.
Honestly, I did that school. I swear I got that. Well, like, she said another answer to her, and I was like, maybe I did it wrong for this reason.
All right. If you take a derivative of x squared, this one's 2x. But if you take a derivative of y squared, that's equal to 2y dy dx. Now, since we know that dy dx is the changing of y over changing of x, that means the delta y over delta x, that means the slope, that's why derivative is a slope. But today, we're going to look at something a little bit different. Today, we're going to look at, we are starting with a related rate, which is we want to take d of dt. So we are taking derivative respect to time. We're taking derivative respect to time. We're taking derivative respect to time. Let's just start with a variable. Let's start with a x squared. So normally it would be 2x times dx over dx. But in this case, you are doing implicitly doing derivative respect to time. So therefore, you're going to get 2x and a dx dt. Is that okay? 2x times dx dt. Is this okay?
Yeah.
Because there are two layers. First layer is the x squared. Second layer is the green layer. So you take a 2x dx dt. Now what we're going to do is we're going to look at these questions. We say, okay, things like this, you can understand that anytime you have a variable, you're going to have d of that variable over d of t now. But what's dx of dt? This means the changing of x over changing of time, which is the rate of change. Like how fast is x changing respect to time? Not respect to x anymore. So this is talking about speed of something. Is this okay?
Yeah.
Okay. So let's review geometry. Review geometry. The reason why we need to know a lot of geometry relationship, and we need to worry about that. So start with rectangles, and you guys should know how to find area of rectangles. What's area of rectangle? Is length times width. Okay, length times width. Good. And that's very important. How do you find area of triangle? What is it? Area is equal to half base times height. However, the other formula you didn't know about. In pre-calc, you actually learned this. AB sin C. I don't know if you remember that.
No.
Yeah, I did. I did. I did. Okay, so an equilateral triangle. So if you have an equilateral triangle, there is a something that is going to be matter here. If the side, if they are area triangle, there is a formula for this as well. Do you guys know? Yeah, 1/2 A, B, and C. This is A, this is B, this is C. C is angle C. And I'm gonna tell you why that's if 1/2 A, B, and C. If you drop an altitude here, you have an A, right? So it's still area is equal to 1/2 base times height. In this case, is equal to 1/2 base. But what is height? Height is SOHCAHTOA. So it's gonna be sine of C equal to A over no H over A. No, yeah, H over A. Do you see that? If you look at the sine C, right, is the height, which is the opposite of C. And then this is the hypotenuse. So it will be H equal to A sine C. So that is why this is A sine C. So it's equal to 1/2 base, 1/2 AB sine C. And that's a reason why there was actually another formula from pre-calculus that you're supposed to know, and that will be help you for later. Now, do I have to know that for SAT? No. So that's just a little bit more extensive, but this one on SAT, equilateral triangle. So when the angle are congruent and the side are congruent, what is the area of this triangle? No, that's S. You're right. You're on the right track. Okay, so imagine I draw a altitude, and that's gonna form at 90 degrees, right? Now remember, this is angle bisect, so this will be 30 degrees. Would you say? And this will be 60 degrees. Would you say? So how would I find the height? Well, it's 30, 60, 90. So the 30, 60, 90 is like this, right? If I have 30, 60, 90, this one is going to be 2x. This one's x. This is x root 3, right? So what happened here? This is a s. So what happened from here to here? It's s over 2, right? It's divided by 2 because it's facing 30 degrees. Half. Right? And this one is going to be what? S over 2. And then this one's going to be S over 2 square root 3, right? So remember, area of equilateral triangle is the 1/2 times base, which is the S, times height, which is square root 3 over 2S. So it'll be square root 3 over 4, sorry, square root of 3 over 4S squared. And that's the area of equilateral triangle. Now, is this happen on SAT? Sometimes. On older SAT, yes. On the new SAT, probably not. But maybe on the highest level question, maybe on module 2, on the end. Yes.
That's square to s squared.
Square root 3 over 4 s squared, yes. Because the height is s over 2 square root 3, and the base is s, so it's 1/2 s times s over 2 square root 3, so it'd be square root 3 over 4 s squared. So this is how you find area of triangle if they are equilateral triangle. Actually, there's third way to find area of triangle. It's called Heron's formula. Heron's formula is if you have all three sides, and you can figure out the area of triangle if three sides are given, and it doesn't have to be the right triangle. It could be any other triangle, but that one's not that important. Yes,
How do we know it's the equilateral triangle?
if three sides are congruent, or the angle are congruent. All three angles are congruent. So that's called equal angular or equilateral. But if you are equal angular, then it also means equilateral. On triangle, it doesn't work with rectangle because equal angular, rectangle is also equal angular, but it's not a square. So that's that. Any question about the area of triangle? Now, is this one on the test? Not too much, sorry. So if I have now, what will be the next one that is very important? Is area of parallelogram. This is not on the test, but it's on SAT. Parallelogram. How do I find area of parallelogram? You don't know? Now you need to know. If you have parallel, that means you have a two pair of parallel line. So it's going to be this. And they don't have to have an equal length. Well, you have one pair equal length, the other pair equal length. So that's why they call it parallelogram. The area is equal to base times height as well. Is that okay? Now I would like to talk about area of trapezoid. Now this one is good for calculus because there's actually something called trapezoid rule. Trapezoid rule. Is that okay? What? Trapezoid rule? Oh, I didn't write it yet. So I have a here. So what's constitute for trapezoid rule? What's the requirement to have a trapezoid? One side of parallel line. Good. Who says that?
Andy.
Okay, good job. So one side of parallel line. Do they have an equal length? No, it doesn't have to have an equal length. But what's area of this? What's the area of trapezoid?
B1 plus B2 over something.
You're doing great so far. Anybody can help her finish? B1 plus B2 what?
Times height.
Good. Is that okay? Now, why is B1 plus B2? This is called the average of base. Why is that you need an average of two base? Well, imagine this, right? On here, we got 5, right? On the top, we got 1, 2, 3, 4, 5. On the bottom is 1, 2, 7, and 12, I believe, if I counted correctly. Did I count it correctly? 5, wait, it's 11, right? Sorry, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, 11. Okay, what's the average of two base? 5 plus 11 divided by 2 is what? 8, right? So let's check out where the 8 is. So I'm gonna draw this, and I'm gonna draw this, and I'm gonna draw it here. I'm gonna draw it here. What will happen? Because the average of two base, I kind of like take the average between 5 and 11. It's gonna form an 8, and for an 8, this one is gonna fill into right here. Does that make sense? And this one's fill into right here. So it's still finding the area rectangle, but you just rearrange the shapes where you average the two base. And the reason why I average two base is because that's if you cut off, let's just say you have a extra length of here, right? You cut off right in the middle and you put it right here. And you take out extra length, you take out half and you cut out right here. That's why you get an average between two bases. And that's how you get 8. And the 8 times height is going to be like this. Is that okay? So that's called area of trapezoid. Now, trapezoid is going to be very, very important because in terms of calculus, maybe not in this particular section, but this is kind of review all the geometry for calculus. So in this particular section, there's actually a trapezoid rule happened in chapter 4. For us, we don't need to do it with the related rate. Not yet. Okay. Area of a circle. Oh, sorry. Area of square first. What's the area of square? Okay. What is the perimeter? 4s, right? That's easy. So how about area of a circle? Jacob, what's the area of a circle? Okay, I remember a 9-year-old girl I tutored outside the school. And I'm trying to help you. I'm not trying to make fun of you, trust me. If I make fun of you, I'll tell you. The area of circle, and I asked her one day, I said, hey, do you know what the area of circle? She says, I remember. And I was like, well, how do you remember a 9-year-old or 8-year-old? She's like, well, my mom always told me this, and literally she just write down a sentence. I didn't get it at first. I thought it was kind of interesting. She basically just said that to me, pi r square. Literally like pi r square. It doesn't make sense, right? Pi usually circles, but she says pi r square. And that's how she remembered it. I thought it was really interesting. I thought it helped me for teaching like kids at her age, pi r square like this. Now, here's an interesting thing though. You know the circumference, right? What is circumference of a circle? Let's just, that's Winston. What will be the circumference of a circle? 2 pi r. But do you realize that if I take a derivative of the pi r square, I get what? 2 pi r. That only work with circle though. This relationship, right? This relationship of the derivative, that's only work with circle. Only work with circle. It only work with circle. It doesn't work with any other shape. So area of circle. So we now talk about a lot of area. Now on SAT, for SAT purpose, for SAT, you also have to know the area of sector. What is area of sector? That means portion of the circle. Okay? So imagine if you have a circle like this, and I have a portion like, I don't know, there's center, and there was like something like this, and something like this. And if this is 80 degrees, and I say, can you find, the SAT question says, can you find the area of shaded region? And if this is 10, can you find the area? So we talk about, in my class, we spent some time to talk about it last year. The area of a sector is basically is percentage of circle times by the area of circle, which is pi r squared, where that's going to be area sector. Why that is? Well, what is a percentage of circle? Well, think about it. This is like a 360 slice of pizza. Okay, Jacob, are you paying attention to me? Okay, 360 slice of pizza. So in this case, it will be percentage of circle. You're gonna say, how do I find percentage of circle? Percentage of a circle equal to central angle. Central angle divided by 360 degrees. Imagine that you have 80 slices out of 360 slice pizza. So imagine that's 360 slice pizza, and I only want to find area of 80 slice. So it'll be 80 over 360 times pi r squared. Does that make sense? It's very easy. It's just understand percentage of circle is central angle divided by 360. Now, with that being said, what if today I say, hey, I don't like crust. I really hate crust. I don't want the crust. I want to find the length of crust so I don't have to worry about the crust. So this crust is going to be the arc length, which is portion of the circumference or portion of perimeter of circle. So in this case, will be a central angle, will be percentage of circle times by what? 2 pi r, and that will be the arc length. Now in pre-calc, you can find it in different way. In pre-calc, there is a formula S equal to r theta. This is the arc length. Yes, thank you. This is the radius, and this is radian in angles. So if you have, let's say, 90 degrees, then you're gonna have to say it's a pi over 2. Right, 90 degree is gonna be pi over 2. So you have to convert to radian. Now I will not use this formula because I think like you had to memorize extra. I just rather memorize, even though calculation is slightly harder, but I don't have to memorize extra things. I can just memorize as a percentage of a circle times by the arc length. So this one, it'll be on the geometry. So I plan to review all the geometry once. Is that okay? Okay. So we finished 2-dimensional. We have finished all the areas. Now we're gonna go 3-dimensional. So 3-dimensional. 3-dimensional, let's deal with a cube. Okay, cube. Volume equal to S to the cube. Volume equal to S cubed, because S times S times S. Now, remember that derivative relationship doesn't work with anything with edges. It only works with things without edges. So in this case, the surface area is gonna be, well, think about how many sides are they? Like in the dice, like if you play gambling a lot, you play dice, and dice have 6 sides, and it'll be 6s squared. Is that okay? So that's a cube. Now, what if I elongate a little bit? So let's just say, hey, let me say this. That's a rectangular prism. What's between prism? Prism is both base are the same. Pyramid is a single point on the other side. So there's prism here. Then it's going to be volume equal to length times width times height. What will be the surface area though? Somebody can tell me what will be the surface area. 2 LH plus 2 LW plus 2WH. Why? Because there was front and back, right? If imagine that this is height, this is length, and this is width. So there's a front and back. So the HL is the front and back. Top and bottom is WL. The side will be WH. So there's two of the sides. So that's the rectangular prism. Okay, what are the two-dimensional shapes that you want to know? Yes.
They're gonna give us these on the formula sheet that you
No. Yeah, this is just a very basic geometry. Yeah, you're supposed to know this if you're gonna do geometry class. Only in America, people don't know anything. But everywhere else in the world, if you go to, I don't know, Syria, and you ask a random person, like, what's area of triangle? They will tell you 1/2 base times height. But if you go out of this classroom and you ask them what's area of triangle, they'll be like, I don't know. 6, 7. I have no idea, but that's what it was. They won't know. But that's the thing. So it's only in America. We don't know shit. Sorry, I just demonetized myself. Anyway, not like I make 2 cents matters. Okay, so anyway, so rectangular prism is this. Any other shape I need to know? Cylinder. I like cylinder. Okay, cylinder. It's actually interesting as well. There is a circle top and bottom. Okay, so what would be the volume of a cylinder? Anybody besides Lian? Anybody that's Lian and Andy? Andy will be okay. So anybody besides Lian and Andy can tell me what's the volume of cylinder? Max? Pi r squared times height. Thank you. Okay, so what will be the surface area though? That's a tough one. What will be a surface area? Yes, Emily?
Isn't it just 2 pi r, right?
No. But you're somewhere. What you did is you find a lateral area. It's different. Yes.
Isn't 2 pi r squared times plus h 2 pi r?
Yes. That's correct. So look at it. This is a sheet of paper, right? If I roll it up like this, that becomes a cylinder, right? So if I roll it up on the top, this is the circumference of a circle. And this is the height. So basically is you have 2 circles. This is top and bottom, right? And you got a rectangle. What'd you say? Is that okay? So this is a pi r squared, and this is a pi r squared because top and bottom. And here is a height, but here is the circumference, which is 2 pi r times 2 pi r. Yeah, 2 pi r is the circumference. So this one is going to be 2 pi r squared plus 2 pi r h, because this part is the circumference times the height. So a lot of times if people don't understand this, it's not as hard as you think. What's the next shape you want to know?
sphere.
Huh? Not yet. Not yet. One more shape that related to cone. Right? Cone, right? So one volume related to cylinder. So what is the cone? What is the cone volume? That's not a triangle.
Yeah.
Well, it depends how you cut it. Wait, you cut it like this, it's a triangle slice, yes. But what is a cone? Obviously, you don't know. Okay, fine. Huh? No.
Substitute water. Why not do it in the English? Exactly. Isn't the English word for
I show like little kid like this. I teach a lot of outside school kids, and I teach them. I says, hey, so this the height are the same. This comb and this cylinder have the same height. Like my favorite class to teach is actually geometry. It's not calculus. If I teach geometry, this will be phenomenal at geometry. Like we were doing all kind of weird shit. So anyway, so its volume is 1/3 of pi r squared h. 1/3 of a cylinder.
You can't see this.
Okay, it's 1/3 of cylinder, so that's okay. It's 1/3 of cylinder. You can probably write it down. It's 1/3 pi r squared h. Now, what else you need to know is this. So remember, cone and cylinder is the base are the same, right? But one is a single point on the top. The other one is a one base. So it actually works the same way with prisms. Prism, because cylinder and cone is basically one is a prism of a circular shape, and one thing is a pyramid of the circular shapes. So in terms of this, actually works out with triangle prism because in triangle pyramid. Actually, any type of angle, any type of polygon on the bottom, the base, it's gonna work exactly the same way. It's work exactly the same way. It's still 1/3. Even though it's pyramid versus prism. Triangular pyramid and triangular prism. Okay? Does it make sense? Now, so that's the cone. Is that okay? How about sphere? We don't need a surface area. It can. They do have a surface area formula for the cone, but involved with a lateral length, lateral height. So I think that's too complex. So we don't want to deal with that. But sphere, what is the volume of sphere? Anybody knows? Raise your hand if you think you know. Yes.
Like 4/3 pi r squared.
Almost. You're almost right. Almost right. Yes, Zephyr.
4/3 power.
4/3 pi r cube. Now, without telling you anything, without teaching you anything, huh? I don't know how to draw a sphere.
Just around circle, like it's a sphere.
Okay, the sphere, whatever. I'm sorry, I don't know how to draw. I'm not. I was gonna say something, but it won't be proper. So surface area. What will be a surface area without me teaching you? Can you figure out what a surface area of this? Without me teaching you, can you discover?
1/3 pi r.
Somebody saying right answer. I don't know who.
Bro, I took the right about my sphere.
Ah, good job, Jacob. 4 pi r squared. Why? If I take a derivative of 4/3 pi r cubed, the 3 is gonna drop, cancel the 3. It'll be 4 pi r squared.
Oh, I have more squares. But I got it.
Okay, so the idea is if you take a derivative of any circular shape, it go to the next dimension, which is kind of interesting. The proof of that is actually interesting. They had to look it up. 3 Brew and 1 Brown. They actually talk about it's pretty interesting stuff. But yeah, that gets too complex, but that's fine. All right, let's talk about triangles. My favorite shape is triangle because triangle involved with a certain thing. So guys, this is called a similar triangle. And I'm going to do A, B, C, D, like this. Okay, A, B, C, D, like this. How do I build relationship on similar triangle? Well, is C over D is equal to A over B plus D. Is that okay? Is smaller triangle is proportional to the big triangle. Proportional, you're going to write down in proportion and set it equal to another big proportion. So it's A over B plus D. Why is B plus D? Because that's the length of a whole big triangle. Now, similar triangle occur on SAT all the time. So this is on SAT and in calculus. Am I going too fast? Now, whatever we're going to go is we're going to talk about similar triangle can occur in SAT in a couple of different formats. This is the most common one. But on SAT, is also show up like this. Imagine that you have two parallel lines and they have different lengths, it's fine. And they're going to crisscross like this. This is on SAT as well. That is because this is called a vertical angle. And this is alternative interior angle because this is a parallel line. And this is called third angle theorem. Third angle are the same. So that just is A, B, C, D like this. You can say is A over D is equal to B over C like this. A over D, B over C. Yeah. You can set it equal to like that. You can set proportion like this. Is that okay? Now on SAT, they do have a one wheel one. It's also similar triangle like this, but it does happen sometimes. Shh, I'm not done. I have a long way to go. I'm trying to help you on SAT and the calculus at the same time. So those three triangles are similar to each other. This is a wheel one on SAT, but it happened pretty often. But to solve this one, it's on my TikTok channel.
You got a TikTok?
Yeah.
How many followers you got?
More than you.
You're so cool.
I am.
What's it called?
Yeah, math.
Yeah, 143. Talking about some more than me. She lied.
I lied. You probably do those 6, 7 stuff on your TikTok channel.
Yeah, you got it.
All right, so is this okay? Okay, so this similar triangle. Now, similar triangle occur in cone. You want to write down in cone. It does occur in cone. I'm going to talk about that. Why is in cone? Because you see it here. Do you see this is a similar triangle right here? And we're going to use that relationship later. So that do occur in cone. Okay. Now we're going to go to a next one is a Pythagorean. Pythagorean is a squared plus b squared equal to c squared. So you have to know this on SAT, and it's very common on related rate. Very, very common. And you have to know your Pythagorean identity. Next thing is right triangle. So they both are right triangle situation. Right triangle situation, you can have A, B, and C. So it's A squared plus B squared equal to C squared. Now for right triangle, and specifically, you want to find out how fast the angle is changing. Over time. You have to look at sine of theta is equal to opposite over hypotenuse, which is SOHCAHTOA. Cosine theta is equal to adjacent over hypotenuse. And tangent theta is equal to opposite over adjacent. Now, do you want to find out how fast the angle is changing? You have to use SOHCAHTOA. That's the only path to find out how fast the angle is changing. You're going to be like, what do you mean by how fast the angle is changing? Imagine I'm looking at a rocket launch. And if I have a video, I have the camera recorder right here. It starts with the horizon, right? I'm shooting straight to the rocket before it launch. But my thing is, my camera angle had to change the angle as the rocket is launching. So it's how fast my angle had to change. Okay? At first, probably going to change faster, but later I'm going to change slower. Because, well, actually, I don't know. Different speed at different times, too. So it's relevant. Okay, so that is that. So SOHCAHTOA. Now, all the related rate question, emphasize, I don't know how to spell emphasize, but anyway, emphasize on what is constant. Something that doesn't change is good. Because something doesn't change is good. We're going to talk about that. If something doesn't change, put a constant there, because something, when you take a derivative, it's completely go away, which is nice. Now we're going to go to related rate. Related rate, we're going to start with these questions. We're going to start with these questions. Yes. So we're going to give you some process for you to, hold on a second, let me go to here, here. Okay. Guideline to solve related rate problem. You can take a picture of this, or somebody take a picture of this, post on the group chat, because I don't want you to copy down, it's a waste of time. But I'm just going to read it to you. Somebody will be nice enough to, I'm going to try this again. Identify the given quantities and quantity to be determined. Make a sketch. Assign the variables. Label the quantity, assign a variable. I would say number one, including assign a variable. Write an equation involving variable with the rate change, either giving or to be determined. Use the chain rule, implicit differentiate both sides, respect to time. After complete the step 3, substitute the result with the all known value and the rate of change to solve the required rate of change. So it pretty much repetitive to using the 4th step. I'm going to show you how I do the first questions. The first question is going to look like, this. The first questions look like this. So I read it. A pebble dropped into the pond and causing a ripple to form a concentric circle. And this is very easy questions. So if I drop in a pond, that's going to form a circle like this, like ripples. It's called concentric circle, right? So you're gonna go wider and wider. Now, obviously, that the radius is changing, so the radius of outer ripple is increasing at a constant rate of 1 foot per second. How fast my area is changing? Now, here's a question though. Do they change at the same speed? Or no? Why and why not? If my radius increases at 1 feet per second, is my area changing is a constant or is different?
I think it's different. So it's like quadratic.
Ah, good. I think Andy's got a very good intuitive thinking. So let's start with what is the radius r and changing at 1 foot per second? How do I write that in calculus? How do I write that in calculus? Yeah, dr over dt. Do you see this is changing of r over changing of time? Is this okay? Is this too difficult? So you're gonna write this information in terms of calculus. dr dt is equal to 1 foot per second. Pay attention to the units. Second, what is the unknown? So this is the giving. What is the unknown? Yeah, but in terms of calculus, how would I write it, Jacob? Okay. dA over dt. You gotta help out your buddy over there, Jacob. But dA dt is the unknown. Is that okay? Now they also say when radius 4, because when radius 4, I'm gonna draw a straight line. This is when r equal to 4. Now that straight line just means when r equal to 4. Now obviously r equal to 4, you're gonna have different than r equal to 3 or r equal to 10. The bigger the radius, the more impact on the area, because it gets bigger in terms of radius, but the area's impact is two-dimensional. You follow me so far? What will be the relationship between area and radius in terms of this question? What would it be? Yeah, but what will be the formula I'll be using for this particular relationship when we go over all the stuff? What will be the relationship I'll be using? A equal to pi r squared. Good. We're doing that. Calculation is not hard. What we're gonna do is pay attention to derivative respect to time. In this case, if I take a derivative of a respect to time, what am I gonna get? Is equal to
R dr dt.
perfect. Does that make sense for everybody? Because you gotta have rate of change for radius when you take a derivative with respect to time on the radius square. It'll be 2r and then dr dt. Now I'm just gonna focus on plug in because 2 pi. Now when dA dt, when radius is equal to 4, so that's gonna be 4. dr dt is 1, so it'll be 8 pi. But what happened dA dt when r is equal to 10? Well, it's different because you're gonna be 2 pi times 4. No, times 10, sorry. Right? And dr dt is 1, so it'll be 20 pi. So 25 p, this is a feet square per minute, or per second, sorry. And this is a feet square per second. Now, when radius is bigger, you impact the area a lot bigger because your area is bigger.
Oh.
Yes.
Why is DRBT when you close 4 and 10 1? Is it just a constant?
You mean do you mean this 4 or this 1?
The 1.
The DRDT is 1 because it's giving. It's telling you how fast the radius changing is 1 feet per second.
Okay.
So the ripple is the radius is increasing like a constant speed. This is going like this. Right? But the area's impact is two-dimensional. Because now we got bigger area compared to the area that's big. So the impact of that is changing when the radius is increasing. So that's why they call it a related rate. Yes, Miranda?
Why is it feet squared?
Why is what?
Why is it feet squared?
Because that's a good question. Remember, this unit is the radius feet, right? This is feet, right? And this is a feet per second, right? So feet times feet is equal to feet squared per second. So that's how you get feet. So unit does matter in terms of this. Does that make sense? Okay, so I am gonna write down, hold on a second, I'm gonna delete this. So I'm gonna write down a question. So the air is being pumping into, so if you cannot read it, I'm gonna read it to you. Air is being pumped into a spherical balloon. Now, there's no such a thing as spherical balloon. Most of balloons are teardrop rather than spherical. Because it's hard to build the thing that is actually spherical that's increasing. I would say the close to spherical would be like a bubble, like you blowing bubble. Those are more like a square, more like a circle, spherical. So I think spherical balloon is not realistic. So, but regardless sake of this question, we says air is being pumped into the spherical balloon at a rate of 4.5 cubic feet. So 4.5, this is going to be 4.5 cubic feet per minute. And you want to think about what is that in term of calculus. And find the rate of change of the radius when radius 2 feet. So how would I write down the giving? How would I write down the unknown? How would I write it down? Right? The giving unknown. And what kind of relationship I'll be using? So can you tell me what's the unknown in this case? What's the giving? What is the giving? In terms of calculus. DRDT is giving? I don't think so. It's dVdt. Why? Look at the cubic feet. Cubic feet is affecting the volume, not affecting the length. Right? Cubic feet means feet times feet times feet. So that's dVdt. Is that okay? dVdt, and it's being pumped in, so dVdt is equal to 4.5, which is also equal to 9/2. For the sake of the problem, will be easier if I write down 5 feet per minute. Is that okay? Is that okay? What will be unknown? According to the question, what will be the unknown? DRDT, good. DRDT is equal to the unknown when R is equal to 4, and that's what you're going to do. What's the relationship on this case between volume and radius? Huh? Radius 2? Okay, radius 2, sorry. What is it? What is the relationship?
V equals 4 over 3 pi r.
V equal to 4/3 pi r cubed. Yes. So what do we have to do with this relationship? Respect to what? Time. So I'm gonna get dv dt is equal to 4 pi r squared dr dt. Is that okay? Now what's dv dt? 9 over 2 is equal to 4 pi. R is what? 2 squared and the dr dt. And if I want to find out how fast the radius is changing, guess what? I'll just divide everything on the other side. So 9 over 2 equal to 16 pi dr dt. And dr dt, divide both sides by 16 pi, will be 9 over 32 pi. And that will be how fast the radius is changing. If that's okay. How much time I have?
20 minutes later.
Huh?
20 minutes later.
20 minutes? Good. 9 minutes?
No, I thought like we're like, yeah, we get out at 11:06, so we have like.
We got 24 minutes.
Okay, yes.
When are we gonna know when to use volume and when to use surface area?
That's a good question. Depending on the question. If I ask you how fast the surface area is changing, then I will use surface area.
But it didn't say whether it was volume, surface area.
They give you value. Lee. Did you fall asleep? Okay. So in China, or in Taiwan, sorry, I was not in China. So, I was in Taiwan. That was a long time ago. Like the teacher allowed the big kids with this thing, yardstick.
Are you still live?
Huh?
Are you still live?
Yeah. So in Asia, we beat kids. But they're so good at math because we beat them. So right here we have a yardstick. I'm gonna ask a simple questions. Wait. The webcam captured.
Oh, never mind.
Where's the webcam capture again? Where?
Down into video and audio.
Yeah.
Mr. Ye. Mr. Ye, I can use the bathroom real quick. Yeah.
Yeah. Okay. All right. So what we're gonna do is wait. Where's Mike? All right. So here's the question of the ruler, and we're gonna pretend that this is a ladder. Okay. So my question is this ladder here that is leaning against the wall like this. Okay, if you guys cannot see, you can move forward too. So it's leaning against the wall. And I tried to.
Super chat.
Someone subscribe.
Oh my god.
All right, I need a like. So let me. Let me post it. Okay, so with that being said, imagine that if I were pulling like 1 centimeter per second. So every second I'm pulling away 1 centimeter, 1 centimeter, 1 centimeter, 1 centimeter. I'm pulling away, right? Hey. Imagine that if I'm pulling away 1 centimeter at a time. Right? I'm pulling away. It's the top of the ladder. Okay, if Apple or Miranda, if you guys cannot see, come up here. It's okay. Okay, so if I pulling 1 centimeter away, am I gonna come down at 1 centimeter at a time? I'm not asking you. Is that true statement? If I'm pulling the top of the ladder at any given moment, if I'm pulling 1 centimeter away, 1 inch, are they gonna come down 1 centimeter?
Yes.
If I'm pulling 1 centimeter. What do you guys think? Why and why not? Yeah, a mental trick question. There's multiple trick questions we're gonna ask throughout this preliminary section. Do you think if I'm gonna rephrase again, if I'm pulling 1 centimeter away, are they gonna come down 1 centimeter?
No, you're not.
No.
No.
1,000%.
Right. I don't think so.
Yes.
Okay, which people think they are the same? Raise your hand.
No.
One person? Okay, separate think you're the same.
Wait, what?
Here, Max.
Is it the same length? Is that the same?
I don't know.
No.
I cannot tell you. Okay. Which people I think are different? Okay. If I'm being very specific. If I'm really specific about things, I'm talking about throughout the whole time, right? Are they always gonna stay the same?
Oh.
Hold on, let me let it slide down. So the thing is, that was a trick question. Nobody got a right answer.
Yeah.
Andy kind of did at one point. He said depend on the time. Depends on if it's a 45 degree or not. If a 45 degree, you have same x and same y. Then if you're pulling down at that moment, before you get to 45 degree, let's say it's 44 degree to 46 degree, that might be the same. And that situation, at that one small increment, that instantaneous rate of change at that 45, exactly 45 degree angle, this is from my 45 degree angle, this is actually gonna be the same. But any other time, it's different. The reason being is, if I'm doing here, and we actually, it's on my EMS Instagram page, somebody did the experiment on this. By the way, you can look up on the Instagram page that somebody actually did, I think Tyler did it. They take a 2 ruler to measure the length and how far they go. So you think about it, if I'm going 1 inch right now, do they really come down 1 inch? Maybe not as much, right? But if I'm going here, now imagine if I'm at 1 inch, it's gonna move greater than 1 inch. Because now all of a sudden it going to one moment, it's gonna drop down really fast. And here it only moved like 1 inch. But here it's dropped 4 inches. Does that make sense? So it's relevant. So that's why they call it related rate. It's related to the situation. Any situation are slightly different. All the situations are slightly different. Is that okay? Okay. All right. Let's come back and work on calculus. How do I go back? Move the webcam to the bottom, right? Wait, that doesn't make sense. Where's my iPad?
Look at all the.
There it is.
I won't be here because.
Lee, are you a streamer? You are? You stream your Roblox? Fortnite?
No. Hey, no, it's 4. For my house, it's 4. For my house, it's like 4 hours.
Oh, okay, this is actually better. All right. Everybody say hi. What?
I said it ended up good on the stream. I guess it's all working.
Okay, cool. All right, so we're gonna look at the situations now, and you're gonna have to figure out a 25-foot longer ladder is leaning against the wall of the house. See, the base of ladder is pulling away. Wait, this is not showing correctly though. You know what? Let's redo this. I don't know why they don't do a good job. What?
You should use OBS.
OBS is better.
Like I prefer, but it's up to you.
Is it better screen now? Do you check on the thing? Is on it better?
It's updating still. It's a couple seconds delayed.
It's correct now?
Yeah.
Okay. All right, so we're going to look at this question, a moving ladder. There's 3 parts of the question. We're not going to be able to finish our part, but we're going to finish the first part. To find out how fast the top of ladder moving down the wall when there's a base of 7 feet, 15 feet, and 24 feet. Okay. You guys want to try it?
Yes.
Let me try.
What's the question?
Moving ladder.
The triangle? No shit, bro. If the floor wall is up the stairs, it's the triangle.
The ladder.
Oh yeah.
With the ladder becomes.
Yes.
Yeah. The ladder is like. So this is like
Okay.
12:19.
Now we need to find the floor.
Yeah, exactly.
Yeah. And then we can come in.
It's giving you B of
My wife.
B of.
No, it's my No. It is. I didn't realize.
Mr. You have any like the other side?
How tall is the house?
No.
It's tall enough.
We do.
It's more than 25 feet tall.
Yo,
Mr.
Yeah.
Which one should I do? 7, 24, or 15?
Let's just do 7 for now. All right, so we're gonna start with what kind of relationship? Well, we're gonna draw a picture first. Our picture is gonna be, we're gonna try our best. We're gonna assign a variable in this case. So there is a wall, and then there's a ladder. This ladder is like this. Is that okay? And we're gonna assign this as X and this is Y. Before we don't assign anything, then we don't know where to start, but we're gonna assign as X and Y. Is that okay? Now let's go back, look at the question. They say the base of the ladder, what's the base? The bottom or the top? The bottom is moving at a rate of 2 feet per second. So this is pulling away at 2 feet per second. Is that okay? Is that okay? Now, with that being said, you say, okay, well, 2 feet per second, great. We're gonna start from there. We're gonna say, what kind of relationship I'll be using here? What kind of relationship I should be using? Pythagorean, good. Now, x squared plus y squared is equal to the constant square. Now, I'm gonna say constant is your best friend. In related rate, constant is your best friend. That means the constant, the ladder doesn't change in length. The ladder doesn't get shorter or longer throughout times, unless you have broken ladder, which that can happen. But in, yes.
Why is that the constant?
Because the ladder doesn't change in length. You don't want a ladder that changes length at any given time. That's very scary to give you on a ladder. I don't know, Fabian work on construction. He will tell you, no, you don't want to have a broken ladder. That is not gonna end pretty.
What happened once, this one guy fell off, and like most of his like leg got caught in the pool.
Yeah, no, you don't want to have a broken ladder. You pay for your ladder, pay the best ladder you can pay for. It's worth it. That's the one thing you don't want to mess around with. Now I'm pulling down like this. We know the relationship. We know that is, what is 2 feet per second? Is that a dy dt or dx dt? Good. Dx dt is giving, so it's 2 feet per second. Is that okay? Okay. Any questions so far? Now, what do we know? What do we want to know? dy dt at x equal to 7, right? And this is how would I write it? When it's a straight line, x equal to 7. So we're gonna do x squared plus y squared. So the calculation is super easy. Equal to 25 squared. I'm gonna tell you that constant become your best friend, because if I derivative of this, we take it due to respect to time, not x. So it'll be 2x dx dt. Is that okay? Plus 2y dy dt. Is that okay? Is equal to what? 0. That's why constant is your best friend. Because there's no rate of change of a ladder. You don't want to have a moving ladder. Now I'm going to plug in, because they say temporary x is 7. dx dt is always 2. Is that okay? Plus 2y dy dt equal to 0. Then you say, well, what's y? Well, how do we find out y? It's because you have a 7 squared plus y squared equal to 25 squared. So be y squared is equal to 625 minus 49. Y squared is equal to 576. Y is equal to 24. So we figure out y is 24 is also a triplet as well, plus 2 times 24 times dy dt. And I'll go ahead and solve it. So I move everything to the other side. So it's going to be minus 28 equal to 48 dy dt. And the dy dt is equal to negative 28 over 48, which is negative 4 over 12, or negative 7 over 12. Because 2 times 4 times 2 is 28. Which it kind of makes sense. Dy dt is going down. It's decreasing. And it's decreasing at that negative 7 over 12 feet per second. Is this okay? Yes?
What did you do after the y squared equals 576?
It's Pythagorean identity. I solve for y. I move the 7 squared to the other side, and I do 625 minus 49 equal to 576. And y is equal to 24. Okay, any questions? Now, we're gonna go to how much time I have? Oh, good. It's not for the other one. Now, you have to do it for 15 and 24, but you're gonna find out they're moving different speed. That's why the bottom's moving away constant speed, the top is constant changing. Is that one time they're gonna move at the same speed? Yeah, but very, very minimum second right when they hit 45 degree triangle. Now we're gonna go to the next question. Consider the triangle area is formed by side house ladder. Find the rate of change in area triangle is changing when the base of ladder is 7 feet from the wall. So we are looking for this area now. What will be the relationship I'll be using? 1/2 base times side, because we're talking about area. Equal to 1/2 base times side. In this case, it's going to be x times y. Is that okay? So A equal to 1/2 xy. Can I take a due to respect to time? Sure. We want to find out what dA dt is. That's okay. dA dt is equal to 1/2. Well, now is what? Product rule. X, well, x dy dt plus dx dt y. Is that okay? I'll just plug in everything. The x, I think, is 7. dy dt, I think, is negative 7 over 12 at that moment. Plus dx dt is 2 times y, I think, is 24. And then you simplify this. I don't want to simplify. Too much trouble. Too much math. But I did product rule. But tomorrow we're going to talk about angles changing. Your homework is going to be posted. It's going to give it to you here. I'm going to airdrop to you. It's multiple choice. Yay.
Please execute the instructions. This is a reminder for students that you are going to lunch based on your 6th period class today. If your 6th period is upstairs, you will go to a lunch. If your 6th period is downstairs, you are going to see lunch today. So again, your lunch may be different today based on your 6th period class. So please take a moment to figure out your lunch.
If you want to stay at lunch here to do stuff, it's fine for me. It doesn't bother me when people stay here at lunch. I'll help you on whatever homework, test, questions, and stuff.
If my second derivative is 0, it is a curve. It's not a sharp point, right?
second derivative is equal to 0. It's a possible inflection point.
Yeah, but like it cannot be a sharp point.
That I don't know. You don't have long enough time.
I think I'll make you.
Huh? You have early release?
No. But my 6th period is that last class is
Can you do it? Huh?
actually is my 6th period, so I can ask her.
Oh yeah, awesome. Or you can do it today too. But today you're not ready.
Are you doing trap?
You guys. Yeah. Have a good day. I talked to your dad already. You just say you're not ready. It doesn't make sense. It doesn't matter. She said you choose not to go to school in the morning. You gotta show up on the test day.
Why is y 2x?
Why is what?
2x. That's what you wrote down.
What did I write down 2x?
Like 2x.
I didn't write down 2x. 24.
Ah, okay, that makes sense. Okay, wait, so